Hi, I'm Tom, and I'm a full stack engineer at Unmind. Today, I'd like to talk to you a bit about the work my team is doing building an analytics platform on AWS, a high-level overview of the tech that we've chosen, and what we're learning about as we go. So, who am I? That's the side of my face when it's not covered in a lockdown's worth of hair. I've been a software engineer for around 5 years, and I've been at Unmind for about 9 months, so roughly one lockdown baby. Unmind itself is a workplace mental health platform which helps employees in organizations look after their mental health proactively through both our web and mobile apps. This can be through self-guided programs, helping with things such as building resilience, managing conflict, or overcoming burnout. We also offer several quick in-the-moment exercises that we call tools, covering topics like getting to sleep, increasing your focus, or just basic yoga. These features can be audio, video, or chatbot based, with usage and completion recorded. We also offer periodic questionnaires which people can use to track their mental health over time. From the employer side, we provide anonymized, aggregated data so organizations can understand how their people are in a way they never could before. So as you can imagine, this leaves us with not masses, but actually quite a reasonable amount of data that we need to use. At high level, we have two sources of data that come into us. There's data that's input into our app. So this is primarily through using features like completing questionnaires or using diary-like functionality. Then we have analytics data, which is the kind of thing you'd often collect through Google Analytics. We use a suite of tools for this, and to bring them all together, we use a tool called Segment. And right now, the main way we use this data, the analytics data is used by our product teams to ensure that our features are working the way that we expect them to. We use this data to build out reports, which goes to our clients on a regular basis. And we also use this data to build out white papers and participate in research studies. Moving forwards, we have aspirations to plug this data into machine learning models to power things like recommendation engines. So we've been around for a few years now, and whilst we managed to pull this data out when necessary, we've got a few things that are going to become a bit more painful as we scale, and we've got to the point that we need to address them. So currently, our data is spread across multiple databases using different technologies. This requires a lot of knowledge of our inner workings, and it isn't the simplest to work with. We really want to have one place where we can access our data. So like I said, to get that data, we have to get it out of multiple databases. Unfortunately, one of those is actually our production app database. So this has worked so far, but again, as our user count increases, we don't want this loaded on our application database. Additionally, whilst we're confident in our data security, having this data outside of our application database will give us an extra level of isolation with regards to who can access it. And to get the data out of that database, the only way to currently do it is through SQL. And as we mentioned, while we like our data team to not access it from our production database, on the other hand, we really like them to be able to pull this data from data stores suited to big analytical queries. Additionally, our internal teams, so teams like our sales teams or client success teams, they don't have a way to get hold of this data themselves. They cannot self-serve. And we only have a limited amount of resource that we can dedicate to those teams to pull out this data. That resource is quite often product engineers who could be making more features. And additionally, we don't currently have a single place where we store our business logic for working out what our calculations are and working out our metrics. So this leaves us with the possibility of inconsistent calculations if people are doing it in different ways. We really want this to be defined in one place. So work to address this was important. And the business was keen to devote resources to it, but at the time that we wanted to address it, we didn't actually have enough resource in our data team to do this. We did, however, have some expertise in our product teams. And so knowing this, we brought in some third-party expertise to help us. We have a long relationship with Scale Factory, an AWS consulting firm, and asked them to come in and do some workshopping with us. Now, I wasn't at these workshops, but you can kind of imagine how this went. It went down the kind of classic route of let's do the biggest thing possible and do the best thing, the most amazing thing, and get really overexcited. What you can see here is an engineering manager redesigning our entire app so we could access our data. Very quickly, we moved to something a bit smaller and more manageable, which would allow us to deliver value quickly. The consensus that we reached at the end of this was to try and leverage a technology called AWS Glue and S3 object storage to build out a data warehouse solution. Now, there's some jargon in there, but before we move on, I think it's important we talk briefly about what a data warehouse actually is. So according to the internet, a data warehouse is a repository for structured, filtered data that has already been processed for a specific purpose. So from a design perspective, what this means is the data is copied out of where it's normally stored, so like a production or analytics database, then processed or transformed, if you will, before being stored somewhere else to use. They're normally used in conjunction with reporting solutions, so the kind of thing that we'd really like to give to finance teams and sales teams. So after all of this, we finally got to a point where we had the first iteration of what we wanted to build. And what you can see here, we have two different domains. We have our platform domain and something we call segment. In our platform, our main application databases are in Aurora clusters. At the edge of that cluster, we have a read replica. Now, read replica is a copy or a replica, if you will, of our main data that we can access without actually impacting the performance of our apps. Beneath that, we have segment. So segment is, again, where we collect all our analytics data together. And whilst it is a cloud-based technology, we actually hold the data for it, so the database that has all this analytics data, on our own estate. We hold this in a database that's in RDS. So what we wanted to do was use a service called AWS Glue to manage ELT jobs, which would pick this data out and pop them into a data warehouse in S3. At the top of that, we put a service called QuickSight, which is AWS's point-and-click report building solution. This would allow our business customers, so again, sales teams, finance teams, etc., to be able to build reports. We'd also put Athena on top of this. Athena is a solution which allows you to run SQL queries over data stored in S3. Now, notice I said ELT job there rather than ETL. I also said data warehouse instead of data lake. We actually meant ELT at the time, and we meant data warehouse at the time. But this is a relatively good demonstration of getting everybody on the same page pretty early. The data warehouse and data lake are very different things. So I keep saying ELT, I keep saying ETL, and I keep talking about Glue. I think it's worth taking a minute just to talk about what those things are a bit. So if you have ELT or ETL, no matter what the order is, the letters actually mean the same thing. E refers to extract. This refers to getting data out of your original sources. In our case, our production database and our analytics database. The T stands for transform. So this is running whatever business logic or calculations you need on that data to form your metrics. So things like a weekly active user, a monthly active user. And the L stands for load. This is taking that transformed data and placing it somewhere else. So that could be into your data warehouse, for example. And we wanted to use AWS Glue to manage this for us. So Glue is a managed service in AWS that does the whole process for you. It will discover the shape of your data. It will transform it in any way that you've asked it to do so, and then put it somewhere else ready to be used. So that diagram before was pretty much the last step that we got to before we started work. We put a team together and brought in another consultant from Scale Factory for a couple of months to help us get started on this. That's pretty much when, as these things go, we discovered that what we wanted to build and what we actually needed to build were quite different things. So the first thing that changed for us is we changed how we used Glue. So the first thing we wanted to do is get something out of our data collection database and pop it into S3. We realized that Glue, whilst it was great at discovering data and building out your ELT tasks, having looked carefully at it, we realized it was a better solution for organizations that need to discover their data dynamically. The shape of our data doesn't actually change very often. Additionally, Glue ELT scripts are output or for custom scripts written in either Python or Scala. Now, traditionally, we are TypeScript or JavaScript shop. And these are Python and Scala are languages that our teams aren't really quite as familiar with. So with these two things in mind and need to move forward, we played to our strengths and decided to handle the ELT side of this using lambdas. Lambdas are serverless functions, so basically compute from nowhere. And once we started to do this, we realized actually we still wanted to be able to query this data in Athena. So the easiest way to get data into Athena is to use Glue, which we decided to abandon. Fortunately, we didn't have to abandon it entirely. So Glue has the concept of data catalogs. Data catalogs are a reference to are basically the index to the location of your data, the schema of that data, and the runtime metrics. Really, really cared about the schema here. And with our lambdas, it turned out that we could actually use the Glue API to build out these data catalogs and then load them into Athena. This allowed us to just use the one part of Glue that we wanted and still be able to build all of this stuff in a language that we understood and architecture that we were very familiar with. Additionally, aware of our resources, building these, handling the ETL or ELT side of this in lambdas allows our product engineering teams to extend them when we move forwards. So what this means is if we build out a new feature and we want to bring data over from that, these engineering teams can handle them themselves rather than throwing the task over the wall to our data team or having to learn languages that they're less familiar with. So we started building out and experimenting with these lambdas, and then we had to put them actually into the cloud, as you do. Enter infrastructure as code. So classically, infrastructure as code is a huge subject and quite outside the scope of what we're going to talk to today. But effectively, it's an approach to building our IT infrastructure using code, as opposed to using a GUI or ClickOps, as it's sometimes referred to. This has benefits like being able to rapidly deploy identical architecture, having source control for your architecture, so i.e. monitoring changes, and everything that's great and hard that comes with code. Historically at Unmind, we've used a mixture of serverless framework and CloudFormation, but we weren't really confident that either would be the right choice for this. Serverless framework is great, and whilst it's grown massively outside of its original scope, it didn't really have enough in it for us to be able to deploy the architecture we needed. CloudFormation is also excellent, and we use it extensively, but it's quite low level, and the learning curve for it is really steep. Looking to get something a bit more developer friendly, we settled on using AWS CDK, AWS Cloud Development Kit. This is a relatively new bit of technology. It's only been around a few years, but it allowed us to write our infrastructure in TypeScript. Doing this again, I don't think we would really do anything different here. We would make different choices, but we definitely learned some things. Firstly, if you're going to pick a new approach to infrastructure as code, give yourself a lot more time than you think to use it. It takes quite a long time to bed in with it. We endeavor to follow the principle of least privilege when we set up our infrastructure, giving our code only just enough permission to be able to do things. However, finding out what these permissions are in AWS can take some time. You'll find suggested permissions for services across the internet, but if you end up copying and pasting these, you can end up being slightly too permissive. Give yourself plenty of time to deal with this and work this out, and bear in mind it can be really frustrating. Alongside that, it's very easy to conflate the frustration between building out infrastructure as code and actually provisioning services in AWS. Nowadays, when we're building out bigger parts of our infrastructure, we quite often do quick proof of concept using ClickOps, so actually building out the GUI, then before moving to code. This allows us to familiarize ourselves with the service before approaching them with code itself. So the next kind of wonderful learning that we got was the working between either ELT or ETL. So like I said, those letters all mean the same things, but actually they had quite a different effect on us than what we wanted to do. Originally, we were going to go with an ELT approach where the data would have been extracted using our lambdas and then loaded into our S3 buckets. From there, we wanted to create using Athena, which would handle our calculations or our business logic, which would have effectively been our transform layer. This would have allowed stakeholders to build reports in QuickSight and our data team to query the data in Athena. Job done, right? Well, we kind of missed a couple of bits. Once the data was in the warehouse, we'd intended to load it into QuickSight in a format called Spice. This is a proprietary format that AWS uses to make it super fast to perform calculations. Unfortunately, as of right now, QuickSight is only usable, Spice is only usable within QuickSight. This would have meant that we could have generated these reports very quickly, but anything else that we wanted to do with this data, so having our data teams access it and play with it and work out all these wonderful things we could do, would have been really quite slow. Additionally, our data teams had a preference to work in tools that data teams normally work with, such as dbt. dbt is a piece of software that allows you to manage your transforms yourself and store those transforms in source control. So we moved away from the idea of this ELT approach and towards an ETL approach. Now, there's a lot more I'd like to cover here, but it turns out I'm trying to do a 30-minute talk in 15 minutes. So the last thing I'd like to show you is where we've got to now. So we are still building this, but this is currently what we are thinking. Everything in the box on the left-hand side is currently built. On the far left, we have our data sources. Data is taken out of those using lambdas, which are in the middle. Collectively, we refer to them as retina for reasons about letting engineers name things. And then that data is passed through to our S3 buckets. We also have a Lambda that builds out our data catalogs. Once you get to the second box, those data catalogs are looked at by a piece of technology called Redshift Spectrum. Redshift Spectrum is similar but different to Athena in that it will allow you to query data in S3. However, it does it in a very different way, which is much faster. It acts as an extension of Redshift, which is a data warehousing solution built into AWS. So on the far right-hand side, we then have our data team and our dbt cloud service. Our data team can now will now be able to run these transformations through dbt, which will pull out the data from S3 using Spectrum, run the transformation, and then load it into our Redshift cluster. So the extract side all happens on the left-hand side. The transform side will happen in our dbt cloud, and then we will load our data into Redshift, which is a much faster and much more suited environment for large-scale analytics. I appreciate that was extremely high level and a little bit quick, so my apologies if I skimmed over anything here. But we are still building this. We're currently at the far right-hand side, and we are hiring extensively through our friends at TechTree and through all other good hiring places. So I will leave it there. Thank you very much for your time.